We're now ready to move on to the third lab. So in the third lab, we're going to create 5 virtual machines from 5 different images, place them all in the same resource group, and then connect them all to the same vNet. So we'll jump in and take a look at the script. So the first thing I do is use this azvm image accept-terms to accept the terms of the Kali Linux image that we're going to be using. So at the time of this recording, that's how I accepted the terms. And then you can use this command to check on the status of your exceptions. Then we create the resource group azfund06. And then we use the az network vnet create command to create a vnet that will be the 172.40.0.0/16 address space. And then I define 5 string objects that are different VM images. And then I combine the string objects into what is known as a collection or an array. And then I use a for each loop to iterate through each object in the array. And then I use a else if block to determine what the VM name will be depending on the image used. So for example, if it finds the Windows 2019 data center, it calls it Win 2019. If it finds the Windows 11 image, then it calls it Win 11-01. At that point, we're ready to create the VMs. We use the azvm create command. And this time we have the image as an object, the network name, and the subnet name defined before we run the command. Then we create the RDP and SSH network security group rules. And then I use 3 if statements to apply additional configuration to the VM depending on what image it's using. If it's using the Ubuntu image, we'll use the same azvm extension set command as in the first lab, and this will pull down a shell script from my Git-Hub repository and then run it on the Ubuntu server. It will install the dependencies for the Nginx web server, download some pictures, and then replace text on a HTML web page with server information. So then when it finds the Kali Linux VM, it's going to use the same command, but it's going to use a different shell script for the configuration. So Kali Linux is a popular pen testing image. So we're going to install some tools that a pen tester might have. So we need to first download this Kali archive keyring.gpg file and put it in the user share keyrings directory. And then we can install Nmap, Wireshark, Tshark, and then PowerShell version 7. And then I use the echo command in bash to create some PS1 scripts that then we can use to use PowerShell version 7 to run the PowerShell scripts on the Kali Linux virtual machine. And the last if block is as if it's the 2019 server, it's going to create a network security group rule for port 80 and the set-azvm extension command to configure the server to be a web server. So right here we're going to install the Windows Feature web server, and then we are going to download the default web page, and then a separate configuration script will be used on the Windows server to get the server information. So here we download some pictures, we create a directory, and then replace text on the home page with server information. And that is the end of the script. It'll just list the open ports for each VM as it's created. So this script does take a while to apply. So I do like to start with a fresh Cloud Shell. So we've got our fresh Cloud Shell, and I'm pasting in the code. And right off the bat, we can see that this command has been depreciated, but at the time of this recording, this is how I accepted the terms for the Kali image. And then we get this nice message that we have accepted the terms. And if we ever want to check on the status, we can use the show command to show us that we have accepted the image. We have created the resource group. So let's check out our resource groups. And now we have the AZ Fund 06-Mixed VMs. We have this nice naming convention for all of our resource groups. We're going to go into the Mixed VM group, and we're going to see our vNet. And when we check out the address space, we'll see that it's using the 172.40.0.0/16 address space. So it's found the Windows 2019 data center server, and it's going to do its configuration. I'm going to pause the video just for time compression. Okay, so the virtual machine was created, and then we applied our network security group rules, and now we get this nice message that it has found the Windows Server VM. And when we go back into the script, we'll see in the third if block the write verbose command that lets us know, hey, this is where we're at in the script. So this particular extension set, it can take like 5 to 10 minutes sometimes for it to apply. So I'm going to go ahead and pause the recording while the extension set applies. Okay, so the extension set has applied. So we're going to go ahead and take a look at what's going on here. So we see port 80 is open, and we've got the public IP address here. So we're going to plug this into the web browser. And then we'll see our status page. So we can see the computer name, Win 2019-01. It's a Windows Server 2019 data center, some information about the CPU, and some information about its networking. And then we also get this awesome message from Megaman congratulating you for getting your Microsoft Certified Azure Fundamentals certification, and then some happy moose and bunnies. So now it's moving on to the Ubuntu web server. And since these are all in the same resource group, what's going to happen is all of the resources for both VMs are now in the same resource group. So they kind of get jumbled up in here, but that's by design. We wanted them all in the same resource group. So the Ubuntu virtual machine has been created, and then we get this nice message that says, hey, we found an Ubuntu VM. So when we go back to our script, we know that we are right here. So it's applying the AZ extension set command. And to check on the status of these extensions, you can click on the virtual machine itself, go down to Settings, Extensions and Applications, and then here we can see the custom script has a status of transitioning, and then we also will get a nice message in the Cloud Shell. This one does apply quicker, but I am going to pause the recording to time compress the video. Okay, so the provisioning has succeeded. So we should get a nice message here in the Cloud Shell. And yes, so we've got the extension finished creating, and we see all of our open ports, and here is the public IP address. So now we'll be able to access the Nginx Ubuntu Linux server. So here we can see the server name is Ubuntu Web 02. It is 24.04.1 Ubuntu. Some information about the processor, and then some networking information. So it's the exact same web page, but one is Linux and one is Windows. So here is the Windows IIS web server and the Linux Nginx server. And this is the Nginx web server from Lab 1, and you can see that it's on a different subnet. Okay, so now it's found the Kali image, and it's creating the Kali VM. So now we're going to see a bunch more resources all jumbled up in here, but again, this is by design. We want all of the resources in the same resource group. So we'll come into the Kali Linux machine. Oh, excuse me. It is, it created the OpenSUSE machine almost instantaneously. So it finished configuring that web server, and then as I was explaining it, it moved to the third iteration and created a Linux SUSE virtual machine. And so with this one, there's nothing fancy about the Linux SUSE machine. I just want to demonstrate how to SSH into these machines. So we're going to open up PowerShell. And it's SSH and admin 03 at the public IP address. The SSH connection has an open port, so we allow our fingerprint to go in, type in the password, and here we are on our Linux SUSE virtual machine. Here you can see it is Linux SUSE version 5.1421. So as I was showing you that, the Kali virtual machine has finished creating, and now it's applying its extension. And again, we can go back to our script, and we can see that we're in the if block for Kali, and it's applying the azvm extension set command. I'm going to pause the recording while the extension finishes applying. And again, you can monitor this from the web portal by going into the virtual machine, going into settings, and then extensions and applications. And we can see that it has a status of transitioning. So I'm going to go ahead and pause the video while this extension applies. Okay, we just got the provisioning succeeded status message. And then we see that we've got our open ports. So I'm going to go ahead and SSH into the Kali Linux machine. So we'll use this public IP address, and it's admin 04. We can see the SSH connection is established. Type in our password. And we can see now we are in the Kali image. So we'll check on Wireshark, which is a GUI-based program. We have Wireshark 4.47. We'll check T-Shark. T-Shark 4.4.7. And then we'll check Nmap. Nmap version 7.95 and PowerShell version 7. So part of the script we're going to change to the user share PowerShell scripts directory. Now I mentioned using the echo commands in bash to create PowerShell scripts. This is where they are stored. There's two of them. The computer name and date, we'll use PowerShell commands to get the computer name and date. And then the Yahoo script, which will import some modules into our PowerShell version 7. So the way you run these is just PowerShell, the name of the script. And we can see that it's using the verbose command to write this information to the screen. So now I'm going to run the Yahoo script. Well, first I'm going to go into PowerShell version 7 and go git module list available. So these are the only modules that we have. But when we run this script, it's going to install some modules for us. And then we get this nice verbose information telling us about the installs. So we'll go back into PowerShell version 7, do the git module list available, and now we have installed these SIM and CyberTool modules onto our Kali Linux virtual machine running PowerShell version 7. So as I mentioned before, you cannot ping Windows servers by default. So we're going to check on our address space. So we're going to go into the vNet, and then our Windows 11 VM has officially just been created. So in our resource group, we now have 5 VMs from 5 different images. Here's the Windows 11 image. So we're going to go into the network and connected devices. And so we already know that the Windows Server NIC, it has this 40.4. So from the Kali Linux machine, I'm going to ping 172.40.0.4. And it fails. So a way that pen testers can find devices on networks is by using a tool called Nmap. And so in this example, the ping failed. So if you're doing a basic ping scan, it wouldn't pick up the server. But we're going to run a ping scan, or excuse me, a port scan on the entire network. Just make sure you spell Nmap right. So this does take just a second to run. And so basically this is saying do a port scan on 172.40.0. every address in the network. And so even though we couldn't ping the Windows server, we found the device. Here's its IP address, and we can see that port 80 is open, port RDP port is open, and this TCP port is also open. And that's and the other important one is this WS-man. So that's the Windows Remote Management Service. So that could be a clue to a pen tester that, hey, this is probably a Windows device. Okay, and so that is our Kali Linux machine. And that finishes Lab 3.